So now just talk about the third case of hydrolysis of salt. Hydrolysis of salt of weak acid and strong base. Whenever we are hydrolyzing the salt of weak acid and strong base, what happens? So first of all, let's form the salt first, right? So it is a weak acid, acetic acid, and a strong base NaOH. When they both react, it form sodium acetate plus H2O. C is initial concentration. Now its concentration is C. So CH3COONA dissociates to CH3COO minus plus Na plus. So in the concentration was C, and it has been formed C molar of acetate ion and C molar of Na plus. So it is actually this will not hydrolysis, this is hydrolysis. So it is anionic hydrolysis, and pH will be greater than 7 in that case. So now as we have seen, I have told you every time we calculate the pH, we go through the 4 steps. So let's talk about very first step, that is general hydrolysis reaction. What is a general hydrolysis reaction? That is the part which will be hydrolyzed. Acetate ion will be hydrolyzed, and it will form CH3 acetic acid and OH negative. So we will be writing the KH for that, CH3COOH and OH negative upon CH3COO negative. Now on the second part, we talk about relation between KH, KW and Ka. So Ka, we could write Ka for acetate ion as acetic acid is CH3COO negative and H positive divided by CH3COOH, and we could write Kw as H plus into OH negative. So we could write this as equation 1, this as equation 2, and this as equation 3. Now if I talk now, let's talk about the third case. The second case, we could write in this case KH. Every time you try to link between K and KW, how do I divide, and also always I tell you in the general hydrolysis reaction, whatever we have on right hand side, we have acetic acid on right hand side, so then the KH term will be KW over whatever the dissociation constant of this. What is it? Is Ka. Now why it is important to do the short trick? Because in some case, in the further some advanced question, you will be finding it is a dibasic or tribasic acid, diprotic and triprotic. Then will be confused. Now whether I write K1, K2. So in the good question, the challenging numerical, whenever it is like H2PO4, HPO4, so you will have to write its dissociation constant as K2, K3. In that case, it will work. So here H equals to KW upon Ka. If I if I go on the third part, relation between KH and H. Third was the relation between KH and H. So CH3COO minus on reacting with H2O, it will form a CH3COOH plus OH negative. So its concentration is C minus CH. It will form CH and CH. So KH was CH into CH upon C into 1 minus H. So KH comes out to be CH square upon 1 minus H. Now again H is less than 5%. 1 minus H will be approximately equals to 1. So here H comes out to be over the root of KH upon C. Right. Now fourth term is derivation of pH. Now how we derive the pH? Fourth is derivation of pH. So we know the concentration of OH negative here is CH. C into H was KH upon C, and it is KH into C. So the concentration of OH minus KH equals to KW upon Ka into C. KW upon KB. It's Ka. KW upon Ka into C. Now, if we go to H plus will be KW upon OH negative. Now KW upon OH negative is under KW into KB into C. Ka into C. Now concentration of H plus is under the root of KW into Ka upon C. So pH turns out to be 1 by 2 pKw plus pKa plus log C. So this is the value of pH turns out to be. Now the problem is calculate the pH of a solution obtained by mixing of 200 ml of acetic acid, whose K is given as 10 to the power minus 5, and 50 ml of 0.2 molar calcium hydroxide. As I told you, you may or may not be given that it is forming a salt. This is a salt hydrolysis problem. Use the direct formula and apply it. Mostly in a good question you won't be mentioned them, so you have to be prepared for that. You have to mix both of them. Now you have to check whether they are mixing equally or not. So let's just check it. So we have actually what we have calcium hydroxide and acetic acid. So if we balance the equation, we have 2CH3COOH plus calcium hydroxide will give Ca plus 2H2O. So here it is actually 2CH3COH plus calcium hydroxide will give this and this. So calcium hydroxide and acetic acid. So 200 ml of acetic acid he may have and 0.1 molar. So the millimole is actually 20 millimole, and calcium hydroxide millimole is actually it is 10 millimole, right? So if we apply the mole analysis, 1 moles of this required 2 mole of this, both will cancel. 1 mole of calcium hydroxide will form 1 mole of calcium, that acetate. Okay, it will form 10. So 10 millimole of calcium acetate will form. So the concentration of this CH3COO whole twice Ca, it is millimole divided by total volume. Total volume of 200 plus 50. It's for 250. So it will be this will be the concentration of this. Now what will be the concentration of acetate ion? It will be the twice of the concentration of this salt. 1 mole of this will give 2 moles of acetate ion. 2 into 10 by 250. So it is 2 by 25. Now it is the question of a salt hydrolysis whose concentration of salt is given to us. So we could now directly use the formula. pH equals to 1 by 2, 14 plus 5, 14 plus pKa, 14 minus pKa minus log C. Whatever the formula we have done, let's check out the formula. pKw plus pKa plus log C. So pKw stands 14, pKa is 5, and log C is log 2 over 25. So we could solve this and calculate the pH of the solution.